Very good morning to everyone. Welcome to my channel Hari PS Videos. Welcome to my channel Hari PS Videos. Like the video, comment the video, share the video, and subscribe the video if you are not subscribed. Right, so let us discuss a concept from class 9 motion. Class 9 motion. So let us discuss one of the concept is circular motion. We know different types of motion: rectilinear motion, curvilinear motion, rotatory motion, acceleratory motion, vibratory motion. Right? Similarly, if any object is moving, the body or the object, the body is moving in a circle or in a circular path. In a circular path is called circular motion. Any object is moving in circle or circular path, we can call it as a circular motion. So in other words, if any object is moving in a circle, you can said to be uniform. You can said to be circular motion. So, for example, an athlete is running in a square track or any other kind of track. Right? These are the different tracks. Then one, two, three, four, five, six, 7, 8. Then so these are the different tracks. So then an athlete is moving or running in different tracks. Observe that here how many times he changes its direction. So for example, square track. So A, B, C, D means the athlete must changes its direction 4 times. In case of this is square, this is another one. So A, B, C, D, E. Pentagon. Right? How many are there? 5 times he able to change or take turns. Here hexagon. So how many times he able to turn? 1, 2, 3, 4, 5, 6. So here the track is changes. Here 1, 2, 3, 4, 5, 6, 7 times heptagon. Then here 1, 2, 3, 4, 5, 6, 7, 8 octagon. So when the sides are increases, then what will happen? The number of turns or the change in direction changes. Right? Similarly, in case of circular track, at every point every point the athlete need to change the direction. At every point the athlete change need to change the direction at every point. So here at every point there will be change in the direction takes place. At every point there will be change in the direction takes place. So many times at every point the athlete changes the direction. We know that if a body is moving with constant speed, while if the direction changes, we can say to be it is velocity. It is a velocity. So here the speed is constant. If the object is moving with a constant speed, when a body moving along a circular path, the direction of motion continuously. So the velocity changed. Therefore, the motion along circular path is accelerated. When a body moves in circular path, uniform speed is called uniform circular motion. As we know, if the speed is constant, when there is a change in the direction, we can say that velocity. In case of circular motion, or if the object is in circular motion, at every point the velocity changes, because at every point the direction is changes. Even the speed is constant, but due to change in the direction continuously, there will be change in the velocity. We can say that the rate of change of velocity or the change in velocity we can call acceleration. Acceleration. So if the body is moving, so if the body is moving in a circular path, or in a circular motion, it is accelerated. So the motion of the body in circular path, or if the body is in circular motion, it is accelerated. So here the speed is constant. The speed of the body in a circular motion is constant. So if the speed is constant, if the body is moving in a circular motion, in a circular path, or the body is in a circular motion, then we can say that kind of motion uniform circular motion. Uniform circular motion means if a body is moving in a circular path, its direction changes continuously, but it has a constant speed. Such kind of motion is called uniform circular motion. Okay, what we have discussed? See, if the object is tried, if you suspended the any object like this, if it is while I willing it. So it is in the circular motion. Circular motion. Here the direction changes at every point, but the speed of this object is constant. If any body is moving in circular path with constant speed, you can call it is uniform circular motion. Uniform circular motion. So any object, if the object if the object is moving, in a circular path, with constant speed, with constant speed, the motion is said to be uniform circular motion. Uniform circular motion. Right? To move the object in a circular path or in a uniform circular motion, we need to require some force. So the force which makes the object to move in circular path, we can call centripetal force. We can call centripetal force. So the force which is required, the force which is required to make an object move in circular path. Is called centripetal force. The force which is needed to make an object travel or move. To make an object travel in circular path. Is called centripetal force. So in this case, for example, planets are moving around the sun. If it is the sun, then planets are revolving around the sun in their particular orbits. Is an example for uniform circular motion. To circular motion, to revolve around the sun, there is a force is applied. That force we can call as the centripetal force. Here, if I want to move this object in a circular path or make it a circular motion, it should be a force is required. That force we can call as centripetal force. Nothing but the centripetal force acts towards the center. Centripetal force acts towards the center. So the object is moving in a circular path. And to maintain the balance, it means the object which is moving in a circular path, centripetal force is required. So centripetal force is nothing but acts towards the center, But if the object is in moving circular path, if the centripetal force acts toward the center, why the object doesn't move toward the center? Means doesn't fall in the center. So here the planets are revolving around the sun because of centripetal force. Centripetal force. If the centripetal force is the force act towards the center, but why these planets doesn't move towards the sun? Because there will be another force. There will be another force also acts. That force we can say to be centrifugal force. Centrifugal force. Centrifugal force is acts outward the center. Centrifugal force act outward the center. That means if the object is moving in a circular path due to centripetal force, but the object is not moved towards the center, it is moving circular path because of some opposite force also exerted by the object toward the center. That force we can call centrifugal force. Centrifugal force acts outside of the center. This centripetal force and centrifugal force are equal in magnitude and acts oppositely. That's why the object is moves in a circular path by maintaining the same speed, by constant speed. So centrifugal, we know that centrifuge. In case of centrifuge, what will happen? Lighter particles are move away, then heavier particles are moved towards the center. Centrifuge we have centrifuge machines we have, right? Grinders, then washing machines. This also works based on the principle centrifugal force. The force which is act outside of the center. So for this uniform circular motion, we have different examples. The first one, artificial satellites move in uniform circular motion around the earth. Artificial satellites move around the earth because of centripetal force or because of the uniform circular motion. Then the moon, which is a natural satellite, also is moving in a uniform circular motion around the earth. So motion of the moon around the earth is also an example for uniform circular motion. If an athlete is moving in a circular path, is also an example for uniform circular motion. So uniform linear motion is not accelerated. For example, if the object is moving in a straight line, so then it is not called as accelerated, because of in a straight line speed and velocity is same. So due to the no change in the direction, due to no change in the speed, so no change in the velocity. So when there is no change in the velocity, we can say to be non-accelerated. If the body is moving in a straight line with a constant speed, there is no change in the direction. So there is no change in the speed or there is no change in the velocity. So that's why then the motion of the body in a rectilinear in a straight line is an example for non-accelerated motion. Whereas in case if the object is moving in a circular path at every point the speed is constant, but the direction it changes at each and every point. The direction it changes. So what will happen? There will be change in velocity takes place. That change in velocity we can call acceleration. We can call it as acceleration. So then tips of handles, tips of handle, tips of seconds, second hand needle in a watch, or in a clock. Clock is also the motion of the tips, or hands of watch, is an also example for uniform circular motion. At every time the seconds one is moving with the same speed, but at every point the speed constant, but every point the direction is changes. So it is also an example for uniform circular motion. So right, so this is about uniform circular motion. If the body is moving in a circular path, we can call circular motion. While the body is moving in a circular path, the speed of the moving body is constant. At every point the direction is changes, so velocity is changes. We know that if any object is moving in a circular path by constant speed and by changing the velocity, we can say to be uniform circular motion. That means if the speed of the body is constant, no change in the speed of the body, if the body is moving in a circular path, such kind of motion called uniform circular motion. In uniform circular motion, the speed of the body is constant, direction of the body changes continuously, so the velocity also changes continuously. When the velocity is changes, then we can say that accelerated. To move an object in a circular path, to make an object to travel in a circular path, we need to require one force. That force we can call as centripetal force. Due to the centripetal force, the planets are revolving around the sun. Right? If any body want to move in a circular path or travel in a circular path, centripetal force is required. But this is act towards the center, but the object cannot move towards the center. It is maintain the same path due to some other force also acts outside the center. That force we can call as centrifugal force. This centripetal force and centrifugal force are equal in magnitude. So the object is moves in a circular path with the same speed by changing the direction. Applications already we discussed. Circular motion, right? Then how do we know the speed of body which is moving in a uniform circular motion? So we know the formula: speed is equal to distance. Distance by time. Here distance is equal to circumference of the circle. The speed, to calculate the speed of body which is moving in a circular path, so distance, that is equal to circumference 2 pi r by t. The speed for object which is moving in circular path, 2 pi r by t. That is equal to distance. So 2 into 5 value we know, 2 into 22 by 7 into r by t. We can write as 2 into 22 into r by 70, right? So 22 by 7 is a constant. So finally, by substituting some values, if you know the radius if you know the radius of the circle, if you know how much time to take travel circular path, then we can calculate the speed of the body, which is moving in a circular path, moving in a circular path. So this is about the circular motion. As already we discussed distance time graphs, some problems regarding the accelerated equation motion, and some problems regarding to graphs also we discussed. Then we have completed our chapter motion. Thank you.